Okay, let us put assignment 4 aside and let's go ahead and continue our discussion of MEP modeling and thinking about kind of tying these systems together. So in order to do that, I'm going to continue with this notion of creating a little building that has a little bit of MEP in it. Where we left the discussion last time is we had talked some about plumbing systems and all the things that sort of work with a plumbing system to get water to drain and how you connected plumbing systems into risers and laterals and things like that. Today we're going to continue the discussion with the MEP systems. Where we left that discussion was really on the whole notion that we tended to size these systems based on just the amount of air we needed to move through a room. So for every room, there were, based on the type of use of the room, there was some notion of, how many changes per hour you needed. So in a room like this, we figured, we might need to move 2,000 cubic feet per minute, okay, based on the number of air changes per hour. But all we really did was we sort of took the volume of the room, so we height by width by length, multiplied all that together to figure out how many cubic feet are in the room. Then we say how many air changes per hour, 4 being the minimum, up to much higher. We figured out, great, so many cubic feet had to move per hour, divide that by 60, and you finally get how many cubic feet per minute. And if that number is 1,000 or 1,500 or whatever that number is, we need to move that much air into the room and we need to move that much air out of the room because we need to get them in balance with each other so that they're ventilating nicely. If you have an imbalance, either if we have too much air in the room and we're not taking enough away, we're infiltrating out, we're sort of blowing out through all the cracks because all that pressure has to be relieved. If you are pulling away more air than you're introducing to the room, then you're infiltrating in and all the air's coming in from the cracks under the doors and the cracks around the windows and stuff like that. And either of those is not a great situation. You like to keep it in balance because if it's all infiltrating through the cracks, you're not really controlling it very nicely. You'd like to be able to kind of control all that in a very engineered way. So let's go ahead and we'll do a couple things. We'll take a look at, I'm going to open up out there. It's sitting around in the session 17, if you believe, folder. Kind of hanging around out there. It's, let's see if I can find this here. Stanford. Session 17. Okay, these architectural model, the MEP model, and the structural model, and let's go ahead and open those up again. Again, I'm going to start with the architectural model, and I'll open the MEP model, and we'll kind of just put those two things in context. So the idea, again, I have this little architectural building. It has a lot of basic information about how the building is going to lay out, but in conjunction with that, I have this little MEP model. Let's open that up. And in this MEP model, we haven't modeled all of the MEP in the building. We've sort of done the ductwork system up for a portion of the building. We've done the plumbing system in a portion of the building. Okay, and just as we're looking at the ductwork system, let's kind of stop and pause and take a look at sort of how this was done. Again, this was done by a student a couple of years ago for this class. We have something called an air handler, which is moving in, it's in kind of the core space of the building. Air handlers really just they just have fans, they pull air through and blow air back out. And along the way inside that air handler, there are some chilling elements or some heating elements just to kind of control the temperature, make the temperature what it wants to be to kind of condition the space, whether we need heating or cooling right now. But from that, we have some supply ducts and return ducts. What I'm going to guess by looking at this is this duct system. The one that's heading out here, okay, is probably the supply system. I tend to actually supply the conditioned air out to the outer boundary of the space. Again, that's where it's changing the most. We want to sort of condition air there and pull it back into the center, kind of create a nice flow. So this other system that's inside here is the return, and it's probably coming on into the inside of that. Okay, and that's just kind of a very basic layout for a system. That's a really common one. The only big consideration you tend to have, let's think about how you go through and design these. Okay, one thing we do is we figure out really where we want all the return locations are. The diffusers that are going to supply air, the ones that are going to kind of pull air away. So, and we can figure out how many of those we need in each room just based on the volume we have to move. So that part's pretty easy. I'm going to go scattering them around. Okay, we tend to have a pretty good location or idea where the air handler is going to be. The trick is how to get all that ductwork from the air handler to all those supply ducts and get it all connected in a way basically that you don't trip over yourself. because there's a whole lot of stuff trying to move past each other within a very kind of small plane of space. It really is hard to get all those things to pass kind of within that space. So you got to come up with some sort of strategy. Now there's different sort of strategies you might use. Okay, ducts themselves have some sort of minimal size to them. You can think about round ducts versus flat ducts. Let's talk about ducts too, in terms of what's going on. Ducts have a volume of air that has to be moved through them. So as you think about the volume of air that has to be moved through a duct, if I was looking at a duct in section, there's a lot of ways I can kind of approach it. If I needed to kind of sort of, basically get like 1 square foot or something like that, or 2 square feet, I could do it a number of different ways. I could go ahead and have a duct which is like 12 inches by 24 inches. I'm kind of cutting in section right now. Okay. I could go through and have some sort of round duct where the total area in there is like 2 square feet. I could go through and have an incredibly skinny little duct, like that 6 inches by like 48 inches. As you go through and try to move air, kind of like most things, like in engineering, kind of the closer to round you can get, the better in terms of the efficiency of the system. We often find big old squarish ducts like this. We occasionally find really flat, kind of squishy ducts like this. The problem is, as we go through and we go routing ductwork through a building, if the shape isn't right and we're trying to push high volume through that, okay, we get noisy duct systems, and we get duct systems where there's actually a lot of static electricity kind of coming through the duct. It's really, it's better not to have things that are sort of too awfully squishy. We can push more air through this than that. It's just sort of a more efficient shape. And then the other thing you have to watch out for with ducts is really this whole notion, every time you put a bend in a duct, okay, it actually loses some efficiency. So if I'm looking at it in plan, running the duct through, just straight through to the terminus over here, okay, is very efficient. If I go through and from here I have to have a bend up here, bend over there, and come back here. At each one of those bends, I'm losing a lot of efficiency. Okay, it just takes more energy to kind of move things around. And what will happen is, if I have to accommodate an awful lot of those bends, okay, we'll actually have to sort of have a bigger duct system to push all the air, to overcome all the inefficiency that we're introducing through all the different bends we're putting in there. So we like to kind of keep things as straight as possible, as linear as possible, fewest number of bends, fewest number of elbows, all those different things. So that's kind of working okay until you start playing around with the whole notion of, I have this amount of space between the floor above and the ceiling below, and maybe I even have some structural work in here. So the amount of space I may actually have available to my ductwork can get very small. You could run up with only 12 inches in here, or 18 inches in here, or maybe 24 inches in here. But within that space, I have to get not only ducts that are sort of pushing air out, but I also have to get ducts that are pulling air back in there without having to bump into each other all the time. So it really gets to be kind of a sneaky wiring nightmare to try and get it all in there and route it all. So we have a couple ways of sort of accommodating that. One thing you'll see an awful lot, especially in commercial spaces these days, is we'll have just an open system where there is no ceiling, and you see all these big round ducts running through the ceiling, and in restaurant spaces, they paint everything black or they paint it some dark color, but it's considered a nice architectural effect, just the ductwork is all exposed. Okay, and that actually sort of solves some of your problem because you don't have to squeeze it in such a narrow space. It's a little bit more expensive, it sounds odd, to run the ductwork all open that way because you have to actually do a very good job of keeping it all clean and looking nice if it's all going to be exposed architecturally. But one thing is, we'll just have sort of an open system. And in some ways, that's really simple. We blow air into the space. We have a lot of space to work with. We don't really have a closed plan. Okay, and often if we do that, we'll do that with round ducts. We have some variations in there. Another strategy for dealing with this is a system like this where we have both kind of a hard ducted like return and a hard ducted supply. So let's say ducted supply and ducted return. These sorts of systems are actually the ones that give us the most control because we're being incredibly precise about exactly where we're pulling it and how much we're pulling. We're really controlling it very, very carefully about just exactly how the air is being routed through the system. The problem with this is that I actually have to sort of find a space for all that ducting on the return. And if I don't have much space, that could be a problem. Okay. Another strategy for doing this that you find used in a lot of slightly older buildings is we'll duct the supply, but we'll have what's called a plenum return. And what's that all about? That's the whole notion that in the ceiling space over here, I might go ahead and run the supply ducts. So I got some sort of supply duct coming through. Everywhere it needs to, it has some sort of drop that goes to some ceiling diffuser. I got one over here that's coming to some ceiling diffuser over there. So I'm supplying the air through a hard duct, but then rather than running a parallel system to pull the air away, I just actually say, you know, there's a lot of airspace in here and there's a ceiling down here. What if I just pull through the entire ceiling and use the entire ceiling space as a big virtual duct? Okay, that's what we call a plenum. So what will happen in here is, in a completely ducted system, I'll have ducts coming down, I'll have some other ducts where I'll have a return duct, and I have to bring it up and over, and somehow I have to find a way to get it to sort of intermingle and do whatever it's doing. I could have some conflicts in there because I got two different types of ducts that are running in the same space. So the alternative to that is saying that, you know, rather than running all that duct work, what if I just went through and put a return air grill in here, and then just in the airspace, I pulled air back just, you know, directly through the airspace, and then I supplied the air through the ducts. Okay, and that's just another way of approaching it. So there's a number of different ways you can do this. Now, to give you a little guidance about all of these kinds of systems, we're going to go ahead and just sort of put some ductwork there, kind of a very simple system. But if you want to kind of play around with this some more and kind of even think about the different systems, let me point you to a resource that may be useful to you. Oh, if you go on out there to BIMtopia or the Autodesk BIM curriculum, there's a number of places you'll find it. Within there, we have, under Unit 4, a lot of information about modeling structural systems, modeling electrical systems, even modeling plumbing and mechanical systems. So for example, in the Lesson 5, the modeling of the mechanical systems, you'll find some stuff in here that actually goes through some of the detail of modeling an exposed HVA system, modeling a closed plenum system. Okay. So just different ways of going through and modeling some of those things. So there's a lot of different techniques in there. Yes, Sarah?
So in the open system, you have supply ducts, but the actual system itself just, there's no return ducts because the return is coming to the system that's supplying.
Yeah, what'll tend to happen, there'll always be some sort of return, but it's really just how ducted it is versus just pulling it like from the general space. In a completely open system, well, there'll often be some, I guess, this is the fairer trade-off in terms of whether you put ducts or put it all to the plenum. In an open duct system, you tend to, even they'll have some ducts that sort of go out to like parts of the restaurant to make sure they're pulling air from those specific spots, because even though it's open ducting, you still want to be able to kind of make sure the air's flowing.
So it really just means there's no like closed ceiling.
Exactly. So you can see all that. So that's why they tend to be these round ducts, which are kind of groovy architecturally, but tend to be a little bit more expensive to run. Okay, but actually very efficient because round ducts are very efficient. Okay, so a lot of information to dig into the detail. Really what you're going to need to do is not really necessarily dig into the detail on all these. We'll do that next quarter. That's going to be what 120B is all about. But really for what you're going to be doing in terms of assignment 5, we want to be thinking about just, trying to get all those ducts through the space and get them not to conflict with the structural system. It's really more about the geometry and making that happen. But let's kind of show you how you set up sort of a real simple system, and we'll go from there. So I'm going to go back over to Revit, and here's an example of where we're going to be getting to, but let's just kind of lay this out one step at a time, see if we can actually make it kind of happen, just in a fairly straightforward way. Okay. As we go through and we start creating different systems, okay, there's this whole issue again about, are we going to put all our information into a single file, or are we going to put it into separate files and sort of split our work? Okay, and it's often good to go through and put it in separate files, especially if you have different types of consultants working on different pieces. That way everyone's work is isolated and we can reintegrate it all together, but everyone doesn't sort of accidentally change each other's kind of hard work. So let's kind of start with that notion and just go from there. So for example, let me close up this more finished version and go back to this architectural space. Here's the deal. Here's the scenario. And let me even kind of open up a floor plan. Okay. The scenario is someone's done an architectural design, kind of like what you've already done for assignment 4. Okay, and put some structural grids in there, kind of like you've already done, or about to finish for assignment 4. And you'd like to go through and start adding some mechanical work to this. So we could add it directly to this file, but maybe a better way to do it is actually create a separate file and link it to this file so that the MEP work is isolated from the architectural work or the structural work. And how you can do that is actually really straightforward. In fact, I was going to advocate that you create a new MEP file, because it's probably better to start with the mechanical template as opposed to starting with the architectural template. That way, all the elbows and connections and ductwork sizes, they're already in there. It's a little bit easier to work with. So go ahead and just start with the mechanical template. We'll go from there. Now, when you start out with this new mechanical template, it looks so bare. There's no information in there at all. I would surely love to bring all that architectural information in here so I could link to it and kind of use it as the basis for my design. And how we're going to do that is just under the Insert tab, we'll find something where we can link our Revit models together. I'm going to say I want to link that architectural model. Here's the one I want you to be ever so cautious about right here. There's this notion of linking by center to center, which is that center of masses in that XYZ sort of space, versus our, origin to origin, and origin to origin is the one that'll always keep you out of trouble. So if you can, set origin to origin, and that way, no matter what you add in, things will always be in coordination with each other. Oh, it's complaining because I have it open in the other document. Let me close it up over there. And again, I'll say link it, bring it over. Don't just do that. I'm so tempted to always just kind of click right away. Origin to origin. Okay, and now you can see that architectural model is hanging out there. At least the ghost of the architectural model is hanging out there, but it's going to be enough to get us started. Okay, now as we are working over here, you notice the architecture model does have some nice grids that are already set up in it. That's going to be really good for keeping us coordinated. Okay. I could just work with the architectural model and its grids hanging out over there, but it is actually kind of nice to make a copy of the grids in this model. That way, if ever the architectural model isn't available to me, I always have those grid locations to reference things to. Okay, so let me kind of show you how we can approach that. What I'd like to do is I'd like to put some grids into my linked model, okay, that reflect the architectural grids that are the structural grids that I've already put in the architectural model. I could just create some new ones right on top and have my own separate little grids. Okay, but I'd actually prefer to have some grids that were a little bit smart about this. So if the architect ever decided to move his grids, my grids would move too. I'd like them to kind of stay in sync with each other. And we can do that by using something called copy monitoring, where I'd really like to copy something out of the architectural model and have a copy over in my model and have it monitored. So if anything changes, those two things are always going to stay in sync. So what I'm trying to do is make a copy, just give me a little bit of independence, but also have a link back so that I always have notification in case anything changes. So as a principle, how does that sound? That kind of makes sense? I'd like to make a copy of your thing, but you can still change it. I'm just going to get notified if you change it. Okay, so here's how we do that. Under, I got to find it, under the Collaborate tab, you'll find this Copy Monitor tool. And what's that all about? That's all about when I want to copy something out of a linked file and kind of keep it monitored. I'll choose that. I got my choice of, do I want to do it to the current project or a linked file? I'm going to choose a linked file. You can actually monitor things within your own file. So if you're sharing with 2 or 3 other people, if your neighbors change something, okay, you'll get notified about it. But in this case, we're going to use it to get notified if anything changes in the linked file. So I'm going to say, let's select that link. And then I'll find the linked file. There's my linked architectural model. Okay, so it is ready to start copying things. So what can you copy, you might ask? Okay, you can copy grids, you can copy walls, you can copy floors, you can copy ceilings, a bunch of different things. I'll even come in here and sort of give you some sense of, what can be in there. Well, we can copy if you've already put in air terminals, if you put in plumbing fixtures, if you put in sprinklers. It's a lot of things that you can copy automatically that are, if the architect's already put some things in the architectural model, you can kind of copy them out. But let me see if we can kind of, even define them in here. So levels I can get, grids I can get, columns, walls, and floors are the biggies. I'm going to go after the grids for right now. So how am I going to do this? I can say copy. And now I have a column A in mind. I can choose copy here. I have a grid B. Copy, grid C, copy, grid D. And I can go through and do it this way. I'm just grabbing them one at a time. Now, why am I doing this? Again, what I'm doing is I want my own copy of them. So let me show you how this works. Okay. The fact that I have 2 copies sitting right on top of each other may be a little confusing because you probably won't be able to see them. But if I, for example, let me go back to the mechanical plan. I'll do it over there. If I turn off visibility graphics, the architectural model, so I can't see it right now, okay, I can still see the grids, at least the grids that are in my version. I just can't see the ones that are copied through. So that's what I'm after. I'm really just about having my own version so that I can kind of use them for reference. So I'm going to say copy monitor. And I'll copy those in too. Now you notice there's also a batch copy in there. Batch copy would let me go through and just grab a whole bunch of things and kind of copy them over all at once, but I'm not going to do that right now. So again, what have I done? I've basically just made a copy, so I have a copy of the grids that match the architectural grids. And the nice thing is, if later on the architectural grids change, I'll get notified and say, hey, by the way, those changed. Do you want to adopt those changes? Or perhaps you'd like to call the designer and figure out what's going on. Because information is power in this case. Okay, so I got those things in there. That's pretty good. I like having grids. I can also copy the levels in. Levels are probably actually a good thing to copy in because, I got my own version of level 1, level 2, level 3, and I'd like my level to actually match your level. Now, in terms of what's going on over here, my level 2 is currently at level, it's about 10 feet. Yours was at level 12 feet. I'm going to take that one out. I'm going to keep level 1 because level 1's still at 0. But in that same copy monitor sense, I am going to grab this and say that I want to copy level 2, level 3, roof, and parapet. Again, why am I doing this? It's all about that if I turn that off, Okay, I have my own sense of levels and grids that matches your sense of levels and grids. Because actually, when I'm going to go through and put in ductwork, I'm going to put it in relative to level 3, and I want to make sure that my level 3 matches your level 3, so that when we get these all together, that we're going to have the same sense of reference about how high up they are. Yes?
If you link it to level 3 and then level 3 changes in the linked model and you update, will it move?
Yes, that's exactly the idea. So I'm going to place some things relative to level 3, like 8 feet off of level 3. If the architect changes level 3 and raises it 3 feet, I'll have the choice. I'll say, hey, you know, the architect changed level 3. Would you like to change your level 3? And then if I change mine, my elements will move with it. Exactly the idea. Okay, perfect. Okay, so I got some levels and grids. Kind of get that idea? Okay, that's just frame of reference. It's nice to have a good frame of reference so we're all talking the same kind of XYZ system. Okay, we are ready to start putting in some mechanical systems. So let's do this. I'm going to go to, the HVAC systems as opposed to the plumbing systems. I have a choice now. I'm going to put some registers. Okay, I'm going to put them above my head. Okay, so in terms of doing that, I can think about putting them on the floor plan. If I'm going to put them, let's say I'm going to put some registers on the second level. I'm going to put some ductwork in the second level of the building between 2 and 3 up in that space. So I can go through and I can put them in, well, I could try to put them in the level 3 floor plan and look down through the floor. It'd probably make more sense for me to put them on the level 2 ceiling plan and look up. It's really either way that sort of makes sense for you, but if I'm going to put them at level 2, I'm probably going to go to level 2 and put a ceiling plan. Okay, so how do I do that? You will notice that over here right now in the ceiling plans and the floor plans, I only got level 1. That's because I took out some levels and recreated some new ones. I need to create some new ceiling plans for myself. Not to worry, I can. I'll go into the View tab. I'll say, how about, where to go? Plan views. Let me give myself a nice reflected ceiling plan. At what level would you like? Well, how about levels 2 and 3? I'm going to work with those. Okay, boom, boom. The roof and the parapet, I'm not going to worry about them having a ceiling plan right now. Okay, it put them in there. You notice, however, it sort of put them in a funny spot right now because every plan has some notion of a discipline and a subdiscipline it belongs to. So if I just wanted to show up in this section of the browser, notice it sort of showed up in the coordination question kind of level. If I want to put them down here, what I got to do is just over here in level 2, say, you know, I really want your discipline to be mechanical and your subdiscipline to be HVAC. That's just going to shove them down into that part of the browser. Okay, it's also going to say that some of the default things that show up will be customized the way HVAC things are. So I'm going to say apply to that. It'll move on down. Same thing over here. I'm going to change it so it's going to be a mechanical HVAC thing. So now they're just down in that place instead. Okay, so far so good? Great. Okay, let's go to the level 2 ceiling plan. You'll see here's my exciting level 2 ceiling. Let's think about this thing. So as we're laying this thing out, I tend to start by actually putting in diffusers or terminals. I'll put in supplies and returns just as endpoints for me to work with. So let's see what we got available. Okay, I'm going to put some things on the ceiling. Some of the default ones that loaded are like little 2x2 ones, so they fit nicely into this kind of ceiling grid. Okay, each of them is going to have a certain capacity associated with it. So, let us say the way the space is divided, kind of this half of the floor and that half of the floor is separate. There's a hallway in here. Let me guesstimate that, maybe on this side we needed about 3,500 cubic feet per minute. I'm just trying to remember. We can do the calculation, but I'm guessing it's around 3,000 or 3,500. Okay, same thing over here. So if I'm going to go through and use terminals that are rated at 500 cubic feet a minute, you can sort of see what the rating is. That would require 7 of them. Okay, 7 returns and 7 replies. 7 returns and 7 supplies. But let's go ahead and figure it out. Actually, even better. Okay, who's hot on the calculator? Who's got a calculator handy? I need a calculator. Calculator? Anyone at all? Okay. I know the space from here to here is approximately, is that 60 feet? Okay, 60 feet. I know the space going in the other direction is approximately, actually I know what it's exactly in just a second here, or more or less. I'm going to leave out a little bit of space on the end. 30 feet. Okay, so someone give me 60 by 30 by 8 feet tall.
14,400.
Okay, so 60 by 30 by 8 is what?
14,400.
Great. Okay, now let's go through and multiply that. Let's say we need a minimum of 4 air changes per hour, so multiply that by 4. Okay, and then divide that through by 60. So what I'm doing is the volume times the air changes. Okay, and I'm going to divide it through by 60, and it's just really minutes per hour. Okay, so what does that come up to?
960.
960? That sounds so little. Okay, how about 960 would be the minimum? That's 4 air changes. Okay, let's say I'm going to up it a little bit. Oh, I'm going to go for like, what does it be, 1980. Okay, which would be 8 times, which would be sort of higher. So now I probably won't actually have something that'll get me to that right away. If I'm using 500 per, I'd use 4 of them. So again, there's sort of this flexibility in terms of the number of air changes. I want to put just a few more in there so that it sounds like I probably could get by with 2, but I'm going to go anywhere from 2 terminals to 4 terminals. And it sounds like anywhere in there is going to be okay. What's the difference? If I have less terminals, I'm moving less air. The air is a little bit stiller. If I'm moving putting more terminals in, I'm moving more air. Okay, the air is just moving its pressure. So in an office space, 2 is probably fine. In something where there might be some fumes or something we want to move away, 4 would probably be a little bit better. Okay, so we're going to put some terminals in here. And we'll just do half the space for right now. Let's kind of do the upper half of the building. On the, where did it go? On the Systems tab, I will choose Air Terminals. You see I have all sorts of connections in here. Let me try Supply Diffuser. Let's see if that actually works. Okay, they are rated at a certain capacity, like 500 cubic feet per minute. We can get different ones in different sizes. We are going to go through and put it at some level, offset relative to a level. So, for example, if it's right now, if I put it at level 2, 0, it's going to be right on the floor at level 2. If I wanted to put them at like 8 feet above the floor on level 2, I give it an offset. I could also say level 3 minus an offset. Yes?
Since we're looking at the ceiling plan, why wouldn't level 2 put it with a 0 offset in the ceiling?
Say again?
If we're looking at the ceiling plan, and that's our basis, then why wouldn't level 2 with a 0 offset put it in the ceiling?
That's actually a very good question. They're really just 2 unhinged concepts with each other. The ceiling is that that's just looking up at level 2 to wherever it is, whatever is level 3. That's a really good kind of theoretical question, but it isn't. Yeah, it's because the plan doesn't actually have sort of a 0 level for the plan. Level 2 just stayed level 2 regardless of whether it's a plan or not. So it's a good question, but it's just not the way it is. Makes you sort of wonder, because it would seem like that there could be a 0 level for the level 2 ceiling plan. Yeah, but it just doesn't have that yet. We could do that. Makes me think. You almost would want to have a level 2 ceiling level. Okay, but yeah, it's not set up that way. And there's a whole philosophical argument about whether you'd like to put a level 2 ceiling level in, or not. But I'll keep it simple for now. So I'm going to put it at 8 feet. Here's what we're going to do. I'm going to go dropping some of these returns in. Oh, whether I wanted 2 to 4 doesn't really matter. Let's Depends on how many air changes I want. I'm going to put them out here towards the outside edge. So there's one. Maybe I'll put 3 in here. The reason I'm going to put 3 in here is if I'm thinking about that kind of structural system, I can see where the grid is. You're going to already start thinking about where do I want to put these relative to the grids, or probably where some of the beams are going to start showing up. You're thinking ahead a little bit to how these things are going to work together. Put them in here. You can kind of lock them into a ceiling location if you want to, center them if you want to, whatever you have in mind. Okay, it probably does make sense to go through and give them some sort of nice location. Line them up. People like it when things line up. Okay, those are the supplies. Those are blowing air out. On the other end of this equation, we're going to put some returns that are pulling the air back in. So, air terminals. Let's go and get some return diffusers. I'm also going to put them about 8 feet off the floor. And I'll put some of them, just closer in on this side. So far, so good. Supplies, returns. Beauty. Okay, let us pause there ever so briefly for our break. Come on back in 5, and we'll actually put a little bit of ductwork to tie this whole system together. So, if you got that so far, we're doing good. From here on out, it's just a running pipe, or running duct in this case.